Are you responsible for specifying fire protection for an aircraft hangar? A warehouse? Or any number of applications or processes involving Class B flammable liquids or Class A materials? Then you'll want to take a very close look at a proven method that provides another dimension to foam fire protection. High expansion foam systems from Ansell. While low expansion foam systems are often specified for the protection of most two-dimensional flammable liquid fires, high expansion foam is typically specified when the hazard has the potential for three-dimensional fires, where water supplies are limited, where excessive liquid runoff will not be tolerated, or where confined spaces could prevent firefighters from reaching the fire using conventional methods. Essentially, the difference between high and low expansion foam is defined by expansion ratio, which simply indicates the amount of foam solution needed to generate a volume of finished foam. For example, an 8-to-1 expansion ratio means that 100 gallons of foam water solution can produce up to 800 gallons of finished foam. Low expansion foams have expansion ratios ranging from 2-to-1 to 20-to-1. Medium expansion foams range from 20-to-1 to 200-to-1. While the ratios for high expansion foams range from 200-to-1 to approximately 1,000-to-1. The typical high expansion foam system consists of four major components: JetX high expansion foam agent, a bladder tank sized to fit the application, a foam proportioner, and one or more high expansion generators. The basic system operates solely on water pressure. Water enters the tank inlet where it surrounds the internal bladder. The pressure forces the JetX foam concentrate through perforated tubes to the tank outlet where it's routed to the proportioner. Simultaneously, water is directed to the proportioner at the same pressure as the foam concentrate. The Venturi effect of the proportioner mixes the foam concentrate and water, creating a 2.75% foam solution, or 2.75 gallons of concentrate to 97.25 gallons of water. The foam solution is routed from the proportioner outlet to one or more high-expansion generators located in the hazard area. Within the foam generator, rotating nozzles spray the solution onto a perforated screen in a circular pattern. Simultaneously, the water-driven fan blows a high volume of air onto the same screen, producing the expanded foam. This expanded foam extinguishes fire in four ways. It carries water to the fire, where it drains out of the foam and cools the fire, the hazard, and the surrounding area. The low surface tension of the draining solution penetrates Class A materials and reaches deep-seated fires. It smothers the fire by reducing the air supply to the fire. And finally, it provides an insulating barrier around exposed materials or structures to help prevent the fire from spreading. It does all of these things using substantially less water and foam concentrate. Just one JetX 15 foam generator can produce a volume of expanded foam at a rate of nearly 20,000 cubic feet per minute, depending on inlet pressure. While most foams can only be used for two-dimensional hazards, the high-volume output of high-expansion foam systems enable both local application and total flooding protection. In fact, because of their unique capabilities, the National Fire Protection Association established Standard 11A specifically for medium and high-expansion foam systems. NFPA 11A Chapter 2 covers total flooding systems for areas like warehouses, tunnels, mines, storage buildings, basements, ship's holds, and engine rooms, and other enclosed areas. The basic concept of total flooding is to fill the space protected to a level above the highest fire hazard.